All right, we are going to be looking at some half-angle formulas today. And so this will be kind of a little bit of a different lesson for you. All right, here we are being asked to find sine at negative 15 degrees. So what you might be tempted to do is to go to your unit circle and go to negative 15 degrees. Remember, 15 degrees is when you spin this direction. So negative 15 degrees would be right about here. And the problem is you don't have coordinates at negative 15 degrees. A few lessons ago, we learned to add and subtract angles that would make negative 15 degrees and go that way. So we could have gone like 30 minus 45 and done sine at 30 minus 45, and then used sum and difference formulas to figure that out, and that is definitely one way to do this. Another way to do this would be to use half-angle formulas. So here's what you're going to do. First of all, you're going to go like this, okay? We could worry about the even and odd properties, but in this case it actually is going to make it a little bit more confusing, so we're going to leave that negative and not worry about it. And this is what I am going to need to do. I am going to need to find a spot that I do have on my unit circle that I have coordinates for that can help me with this, okay? So I have this, sine at, and then I'm going to double that negative 15 degrees, and so I'm going to make that be negative 30 over 2. 30 divided by 2 is 15, and I have coordinates at 15 degrees. So basically you're going to double this angle right here and then end up cutting it in half, okay? So this is the formula you are now going to use, and you can see that you have a formula that looks like that right here. Sine at theta over 2. What's plugged in right here for theta is negative 30 degrees, okay? That's what you're going to plug in for theta, and you're going to use that formula. So here we go. 1 minus, plus or minus, the square root of 1 minus cosine at negative 30 divided by 2. Okay, that is the formula that I'm going to use. Now what I'm going to need to do is I'm going to need to go to my unit circle, and I'm going to need to replace this with a value from my unit circle. So it'll be plus or minus the square root of 1 minus whatever's circled in red there over 2. So I need to find cosine at negative 30 degrees. So I go to my unit circle, and negative 30 degrees is right down here. Cosine is your x value, and so your x value at negative 30 degrees is square root of 3 over 2. So I go back here, and in the red, where it's circled in red, I'm going to replace that with square root of 3 over 2. Okay? Then you need to simplify this a little bit. The square root of 3 over 2 needs to be subtracted from 1, so I need common denominators right there. And I'm going to make that 1 be 2 over 2. And on the top, you're going to have 2 minus the square root of 3 over 2 over 2. Okay? This is like over 1. You're going to, instead of dividing by 2 over 1, you're going to multiply by its reciprocal, which is 1/2. So I'm going to cross that out. And then when you simplify that, you will have plus or minus 2 minus the square root of 3 all over, and then 2 times 2 right there is 4. And then what this really is when you're taking the square root of a fraction, you have 2 minus the square root of 3 all over the square root of 4, because you take the square root of the top over the square root of the bottom. We know that the square root of 4 is 2. So now I'm here. Okay. And now I need to figure out if this is positive or negative, which actually is a little bit easier in this case. Remember that our original problem was to find sine at negative 15 degrees, okay? Negative 15 degrees on your unit circle is right about here, and your sine value or your y value at that spot at negative 15 would be negative, okay? Your sine value or your y value where negative 15 is right down here in your unit circle will be negative, because sine is negative in quadrant 4. Okay, so it's going to be negative, and this is your final answer. Once you have square roots within square roots, you don't need to simplify that any further. You can kind of go from there, okay? All right, moving on to the next one. Now we're going to be asked to find secant at 15 degrees, okay? Very, very similar. Again, I could use sum and difference formulas and add and subtract angles that I have on my unit circle to make 15 degrees, but in this case, today's lesson is going to be to double it and then cut it in half. So I'm going to ask you to find 16, or secant, sorry, and I'm going to double that 15 degrees and make it 30, and then cut it in half because 30 over 2 is 15. So this is what I want you to do now. I can't find, by the way, secant at 30 degrees and cut my answer in half. If that's what I wanted you to do, I would go like that and have the line go all the way across, but I didn't. So you have to follow your half angle formulas. So if I go over here, what I realize is that I don't have a formula for secant, okay? So you have to use your trig proportions, and you have to remember that secant is the reciprocal to cosine. And so basically, to do secant at theta over 2, you're going to take the reciprocal of cosine, and you're going to just simply flip that, okay? So you're going to have it be 2 over 1 plus cosine. Okay, so I'm going to go like this. Plus or minus the square root of 2 over 1 plus cosine at 30 degrees. My theta is 30 degrees here because that's what my top number is. Okay, and then I'm going to go to my unit circle, and I'm going to look up a value for cosine at 30. Okay, so I go over to my unit circle, which I have coordinates for at 30 degrees. Here's 30 degrees. My cosine value at that spot is square root of 3 over 2. So I go there, and I replace what's in the blue circle with square root of 3 over 2. Okay, again, I need to get common denominators with this 1. So I'm going to make that be 2 over 2. Simplify, and I will have 2 over 2 plus the square root of 3 over 2. Okay, and then instead of dividing by that quantity, I am going to multiply by the reciprocal. So that drops off. And then on the top, I have 2 times 2, which is 4. And on the bottom, I have 2 plus root 3. Okay, and then again, when you take the square root of a fraction, you're really taking the square root of the top over the square root of the bottom. The square root of 4 is 2. And the bottom is here. Okay, now I know you have radicals in the denominator, but when you have a radical inside a radical, like that square root of 3 inside the square root of 2 plus root 3, when you try to conjugate that and get it out of there, you're actually going to create more radicals. And so we allow you to leave it right there. So once you have a radical within a radical, even if it's in the denominator, you may leave it, okay? You don't need to simplify this any further. Okay, now again, we are going to be asked here to find whether our original problem was secant at 15 degrees, remember. So when you think about your unit circle again, positive 15 degrees is right about here, okay? And if you look at your unit circle, it tells you which trig functions are positive and negative in that spot. And so secant, or the reciprocal of cosine, would be positive in quadrant 1. So this has a positive root, and here's my final answer. Okay, and I think we have one more here. Tangent at 9 pi over 8. So this one's in radians, and I think it's probably easier to think about this in degrees. So I am going to multiply this by, by pi over 180. Whoops. Okay, so right now this is tangent at 9 pi over 8, and I'm going to multiply this by 180 over pi. Okay? My pi's are going to cancel, and this is going to become tangent at, I have to calculate this, 202.5 degrees. Okay, and again, when you think about your unit circle, you don't have coordinates at 202.5 degrees. And on this particular one, I can't even find things that will add and subtract together that I have coordinates for that will make 202.5 degrees. So I have no choice but to do this with half angle formulas. So I am going to rewrite this, and I'm going to double 202.5 degrees, which will be 405 over 2. Okay, 405 cut in half makes 202.5. So I'm going to go over here to my formulas first of all, and I've actually got 3 formulas for tangent at theta over 2. Any one of those 3 are fine and will result in the same answer. I probably would avoid ones that have square roots in them. I personally like this one because then if you have to conjugate anything, it's not so difficult. So I'm going to choose that one, but you may choose something different. Your theta in this case will be 405 degrees because that's what it is right here. Okay? So your theta will be 405 degrees. So it'll be 1 minus cosine at 405 over sine at 405. Okay? So cosine at 405. I am going to go to 405 degrees on my unit circle, and 405 degrees is more than 1 revolution. All the way around is 360. And then if I go 45 degrees more, I will be at 405. So here's where the 405 degrees is. Okay. Cosine at that spot is your x value. So your x value at that spot will be root 2 over 2. So cosine at 405 will be root 2 over 2. And then your sine value at that spot is also, or your y value at that same coordinate. If I go back here and show you, I suppose I should. Here's your cosine value, and here's your sine value. Okay, so your sine value is also root 2 over 2. All right, now on the top, I need to simplify this by putting the 1 right here. Okay. And I'm going to have 2 minus root 2 over 2 over root 2 over 2. Okay. Then what I'm going to do is I'm going to flip the denominator. So I'm going to have it be 2 over root 2 like that. So I flipped this and I'm going to cancel it. My 2's will drop, so that's good. So now what I have left with on the top is 2 minus root 2, and on the bottom is root 2. Okay, so now I've gotten rid of the double fraction, which is good, but I still have a radical in the denominator. So to get rid of that, I need to multiply it by itself. And then obviously I will distribute this. So I will have 2 root 2 minus, and then right here, root 2 times root 2 is 2, all over root 2 times root 2 on the bottom, which is 2. And then this 2 and this 2 and this 2 can all be reduced. So 2 over 2 is 1, like that. So it'll reduce like that. So here is your grand final answer for this. Let's see. And here will be your homework, and we will see you next time.